Welcome everybody. In this video, I'm going to be sharing personal advice from my experience on what I think you can do to improve your skills as a software engineer. Primarily, what we try to focus on is the code. So what kind of code are you writing as a software engineer? And that's a good area to improve. In this video, what we're going to be looking at more is the planning, the design. What do you do at those stages and how does it actually affect the code that you write in the end? All those gimmicky performance stuff that you will write don't really matter as much as what you do at the planning stage. The advice that I'm going to give you is mainly focused around bounded contexts. We're going to see how at planning at design stage, everything can either go into spaghetti code, and then how will it look like if you've clearly defined your boundaries, and what will that make your code look like in the end? My name is Anton, welcome to the Raw Coding YouTube channel. Don't forget to check the description and let's go. So starting off with the spaghetti example, first of all, let's take at the models. We are doing a shop example. Here we have a product description. Product description will have a stock. So what kind of shoe do I have? And then what kind of sizes of that shoe do I have? They will have individual prices. We then have the cart, and then we have the cart product. Cart product is a linker table between the cart and the actual stock. The stock that you pick up from the shelf and put in your cart, that is the linker table. We then have an order and then an order product. Order product is also a linker table back to the product stock. One thing that you may note here is dry, so don't repeat yourself. The data that we're going to be storing in the database, it's not going to be repeating itself, right? We have doubled down on efficiency over here of how we're storing this data, and we're going to see how it's going to bite us back in the end. When you're modeling your database or how you're going to be storing your stuff in the database, duplication may not be your primary concern. So let's close down the models. Quickly taking a look at the database, so we're going to be using Entity Framework Core, none of my dictionary implementation stuff today, unfortunately. We set up the many-to-many relationships, and then I initialize the database, so we are just going to have the product, we're going to have the cart and the order link to this stock. Okay, and then we have a couple of endpoints. So we're listing the products that we have the cart, and we have the orders, and then we can update the product. Let's fire this up and take a look in the UI. Here we are in the browser. On the products endpoint, we get the product, so the product with its individual stock. We then have the carts, which is in the similar situation, so we have the cart with its stock. And then we have the order with this stock as well. The situation that we're currently in, we're selling a shoe, somebody has a shoe in their cart, and then somebody has already purchased that shoe. What we want to do now is adjust the price, because people are printing money left, right, and center. It's an illusion. Everybody's starting to pay in bitcoins and whatever. We need to adjust the price. For this, we have this simple update product endpoint. What can possibly go wrong? We get some kind of price that we input into a form, and then Entity Framework 7 comes out. We want to use the new syntax, and that's what we're going to do because we're professional software developers. So we got that going on. Let's take this update product. We're going to update the product, and the price updating completes. If we take a look at the product that we sell, it now costs this much. The person that was about to buy the product is taking a look at the price and is like, hold up, this is not what I put in my cart. And then the person that has already bought the product, if he goes ahead and takes a look at the receipt that was printed, he's like, what kind of sorcery is this? How did the numbers change? So when we update our product, we actually want to update our product safely. I'm just going to call this safe actually. What is this updating going to look like? And let's stop the server for now. First of all, what we want to do is preserve the price in the order. That means we're retaining the order product link, and that stock cannot change its price because it's already been purchased. So we need to leave that alone. Therefore, we're going to be creating another entity in the database. That's right. We will need to duplicate the stock entity with only a single price adjustment. We then want to discontinue that product from being bought. So we will need to change our model to be able to flag a product to no longer be available or something like that. And then the product that is no longer available, we need to be able to remove it from the cart and say, sir, sorry, price has changed. This is not the same product as you've purchased, right? After doing some initial work, what we're doing is grabbing the stock from the database. Based on the stock that we've grabbed, we're now adding a new stock and we're saving changes. This is going to preserve the price while also adding another stock to our database. If we take a look at our products, we're now going to be selling two identical products at a different price. This is where we want to go to the product stock and we want to say, look, this item has been discontinued or disabled, and we want to be able to mark it as true. So after we've duplicated this stock, we want to mark it as disabled. So disabled equals true, semicolon on the end. Using this flag, we can now amend our queries to the UI. So when we're querying stock here, we can say where the stock is not disabled. Now we're only selling the latest item, and the last thing that we want to do, and we're going to assume that this is going to be in a transaction, we want to go to the linker table and we want to look for product IDs that we have currently removed. So stock, and this is double equals ID, and we're going to execute delete async and wait on this. Okay, so this doesn't look too bad. Other things you can do is make your data on the backend immutable. So when somebody has created a product, the only way to make changes is to create another new product. So you're disallowing your users from editing things. And that is almost generally never the case with systems that we build. Stuff is editable. And on top of this, if we actually update the product description, all of the stock will have to be duplicated and copied across, because our order product links back to the product description through the product stock. So if you think this doesn't look too bad, your product description update method is going to look twice as worse. Now I'm gonna need to create a migration for this and start the application back up again. So that is running again. We are back in the situation where we're selling a product, a shoe is in our cart, and then somebody has gone ahead and ordered that shoe. We want to update the product safely. This has gone ahead and run. If we take a look at the order, I know the quantity is 100. We've bought 100 of these at a time, super greedy. If we take a look at the cart, the item is now removed. If we take a look at the products that we're selling, there is only a single stock with the updated price. And there we have it. We've essentially are now allowing our customers to safely update products, retain the prices for the customers that have purchased those products, and safely remove the items from people who are attempting to purchase these products. And the cost of that is complexity on the back end. And the reason we have this specific complexity is because of our data models. And the reason we have complexity in our data models is because we haven't understood the boundaries. Now, let's go ahead and close this application. I'm also going to stop it. Before we continue talking about the example with defined boundaries, I want you to first listen to this example, pause the video, and try to reapply this yourself to the shop and see what you're going to come up with. This example is going to be slightly different, and anytime I am modeling new software, I am always coming back to this scenario, and the scenario is books. Think about the lifetime of a book. There is an author and he's writing a book page by page. This is not the book that you're going to buy. First of all, he has to write a draft, and there is actually very good terminology for this. There is a draft that you submit to the publisher, and then the publisher prints, and you're actually purchasing a publication, a published book. The draft can be edited, the published book cannot be. You're selling the published book is going to have a price, the draft is going to have notes, redactions, what it was before, it's going to have versions, and while you're editing the draft, it does not actually edit the published book, right? So these grow in different directions, and that is the split between one context and the next. Go ahead, pause the video, think about where can you draw lines in a shop. Hopefully you had a good think about it. Let's go ahead and continue. So closing down the spaghetti code, let's take a look at the defined boundaries. We have a new component here, a message processor, and this is essentially how you step into, or you can evolve. So a lot of people ask me can I put messaging into, because everybody's using it. Well, this is how you can start introducing messaging into your applications. But first of all, let's take a look at the models. In the beginning, the first boundary that we have is management, okay? These are the people, the workers in the shop. They are going to be ordering stock. where does the stock come from, can we apply any discounts to it, what season is it, how much do we have, etc. Then we have the store. This is where customers are walking around with their carts, with their trolleys, they're looking at the shelves, and this is essentially the concept of a catalog. This is something that you can already buy, not the PS5s that are, in the warehouse that they haven't put on the shelves yet, but they're ready to because there is a release date, okay? That is a completely separate product compared to the catalog item that you can actually buy. Because the catalog item that is on the shelf is also published on the website somewhere, it is purchasable in 10 different ways, etc. Catalog item, the shape more or less looks the same to the product description, but it is not quite the same thing, okay? This may look like duplication, but you're essentially making a distinction. You're making a cut between the management side and the store side. And then the cart contains these individual cart items, where the product description and the stock has essentially merged together into the same thing. And then finally, we have the customer with the order. And there is actually a very interesting distinction that you can make between an order, because an order is something that you place that has to be fulfilled. However, when you walk around in the shop and you buy something, you don't have an order. You get a receipt for your purchase because you make the purchase right there and then. But anyway, another thing that you can notice is that the order item is pretty much identical to the cart item. The duplication here doesn't matter. It's the same code base. However, if you would be doing microservices, these would be different services with their own models. It's okay to have these boundaries in the same project. Let's close down the models. Let's take a look at the database. Here we have all of our tables. We don't have a single many-to-many relationship. And that is going to be quite the theme for the video, where stuff just starts being a lot more simpler. We then have the initialization of the database over here, which is going to put us into the same position. Let's go ahead and close the database and take a look at the program CS. Hopefully, the first thing that you should notice is that everything is looking a lot more slimmer, okay? We are just going ahead and rendering what we have in the database. If we go to the spaghetti models over here, the reason we cannot just project everything as it is and we have these big selects over here where we are supplying these lambdas is because of these linker tables, right? So from cart, we're going to product stock is going to product description is going right back to product stock. Okay, this is an infinite loop. I know you can put settings in JSON serializer to prevent this, but the point is having these many-to-many relationships puts you into these loops that can happen between your data. Over here we have essentially the same update product, and for both of them I forgot to make them asynchronous, but besides the point, it is the same. Let's fire the application up and let's see what we get so far. With the application started, these are the products. If we go to the catalog, here is the catalog. If we go to the cart, here is the cart. And if we go to the orders, here are the orders. So first of all, what do we want to do? We want to go ahead and update product. All right, so let's hit this endpoint. We're going to duplicate this, update product. This has been successful. If we go take a look at the orders, not changed, cart, not changed, catalog, not changed. The amendment that we've made on the admin side, so in the back of the store, we haven't gone ahead and explicitly said, go and update the shelves. From the beginning, by default, we have that safety. There is no magic. Stuff on the other side doesn't happen automatically. We have to write the code. We need to plan this. This has to be a deliberate action to replace the items on the shelf, to again remove stuff from the cart. And the orders, well, we don't have to worry about the orders. For the 4 tabs that I have over here, as we've talked about it, these are essentially, you can call them 4-3 boundaries, where we have the back of the store, the shop floor, and then the stuff that the customer took home. These are essentially boundaries. How do we cross from one boundary into the other? This can be an HTTP call. I personally would prefer event driven. So what you're doing is you're taking a POCO and just putting it on some kind of message queue. The other bounded context is listening for an event. So if a message comes in, an event comes in, you go ahead and do something. And this is where the message processor comes in. We're going to take a quick look at it. We have a message that we can process. This is an implementation of the message, so product publish, and then an interface for the message sync. So this is where you're going to be sending stuff. We then have a background processor, which is also the message sync. Here we have the service provider. We create a channel. So the channel is the thing that is going to be accepting messages and then processing them. If you're depending on an interface like a message sync, you can easily switch from having a background queue and a background task processor to a distributed one. All you have to do is substitute the implementation for this, and then you can just say in queue, publish message, or whatever else you want to call it. We implement this interface, which just writes the message to the channel writer, and then in a loop, we try to safely read the message. Depending on what kind of message we get here, we are trying to process this message. And this is where we're going to implement this. Here's what the initial setup would look like. You create a scope because this is not an HTTP context. This is not a service that is spun up on per need basis. This is a singleton that is just running in the background, which is receiving events that should be processed. We're creating a scope during which this database object is going to exist. We want to remove the item that we have been selling from the catalog and publish another item. Also, any items that have been in customer carts, we want to remove them, and the orders, we don't even need to worry about them because once we actually go ahead and create the order, we fully map the data. That is the kind of logic that is going to exist on that side, making your administrator logic quite simple as well. The code that we end up writing can be really simple as well. The first step is basically the product has been published. Okay, which product? So, okay, this product, let's remove stuff from the shelf. If the customers have it, we automatically reduct it. And then what we do is we create a new catalog item and we stock the shelves with that. And we end up with something like this. Fetch the product by the product ID and then remap it. This logic can be very reusable. And then we add the item and save it to the database. Now, another important thing that I want to mention here, this is a single use case. What if your shop has customers which are subscribing to a newsletter, so when a new product comes out or a product of interest, etc., they want to receive an email? What do? You don't put the logic in here. There's going to be a separate class, a separate handler that is also going to be listening on this message. And that is the power of message-driven applications or event-driven applications. Whereas if you have a CRUD or just a CQRS command where you're saying publish product and then the command is like 10,000 lines long, and inside this method you also surface your email service where you are sending emails, and as the person who is actually the administrator, and he's clicking publish product and it starts loading because it's like trying to do that task, this task, that task, and eventually what you are going to see is a support call from one of your administrators or shop managers, and it's gonna be like, excuse me sir, the website is slow, all I can see is the spinning icon, it is spinning, can you fix this please? And as a developer, that's the last thing that you want to be listening to. So you're avoiding one giant function with many handlers or many subscribers, many listeners to a message. What you do is when you actually go and update the product, in addition to your database, you are surfacing an iMessage sync. And there are a couple of messaging libraries that are currently out there that you can take a look at. And Service Bus, Wolverine, which is a new one. It's quite simple and nice to use. The point is, a lot of people have already done the hard work of handling all the nuances around publishing messages. So, if you're watching this and you're Distributed Master 3000 and you're like, what about the two-phase commit, the persistent message retries? Relax, buddy. So product ID, you go ahead and set it to the product that you want to update. We are updating product number 1. We're going to wait on this. So we're publishing a message, we're updating a product, and because I only have one product, only one product should be updated. I don't have to change my database model to approve of this change. The database administrator is happy. The application should get restarted. Let's take a look at this. So we're back with having this product, and everything is still the same. We'll go to update product. Looks like this has been successful. The order is untouched and the card and the catalog are untouched as well, but the product has been updated. So let's see what is going on. Minor technical difficulties, but after a quick investigation, basically execute delete didn't support cascading deletes, so I have to include options. I have to delete it this way and save the changes. Here we are back at the correct price. The catalog and the card are untouched. Let's go ahead and update product. So that is now successful. Orders are still there. Card is cleaned out from the item. We see a new catalog item with the new price. And then the product on the admin side is now updated. And this is pretty much it for the advice on how I think you can become a way better backend developer by spending a little bit more time at the planning and design stage. Actually understanding the domain that you're in, defining clear boundaries will help you define better models. When you have better models, you're gonna have better processes. They're gonna be much simpler and more succinct, and you're automatically, because you have boundaries, you're gonna be pushed into messaging, where you can start exploring messaging, exploring things like nService Bus, Cloud Message Queues, RabbitMQ, and the like. And the main symptoms that you can look out for is a lot of linking between all of your entities. They're tangled up like spaghetti. And also you have complicated logic on your backend. Sure, it may be split up between classes, but the process, the conceptual model, the context that you're trying to fit in your head as you're looking at that function and all of its components is way too big, and therefore making it hard to work with. This will be it for this video. Thank you very much for watching. If you enjoyed it, don't forget to leave a like, subscribe, come join the Discord server. If you have any questions or want me to do more of these architectural type of videos, suggestions, go ahead and leave a comment. Come support me on my Patreon, get the source code. Very, very big thank you to all of my current Patreon supporters. Your help is very much appreciated. Hope you're all having a good day, and goodbye.